Hello, welcome to 13 Universal Learning Beyond Borders. This is A-Level CIE Biology with Shedro. And yeah, for the very first series of enzymes, welcome to Enzymes. All right, we're going to be doing series 1. So check our videos on biological molecules and cell structures. We've done so many series. And like them, share them, watch them, enjoy them. All right. So let's dive into the question. The first one says, 4 students 1, 2, 3, and 4 counted the number of bubbles of oxygen given off in a minute when investigating the effect of catalase from plant tissues on hydrogen peroxide. Each student repeated the experiment 5 times and calculated the mean number of bubbles per minute, which have correctly calculated the mean. All right, so who is correct there? So I wanted to try this. So in experimental biology, investigative biology, we have what we call a particular skills PDA, presentation of data and observation, right? So in measuring bubbles, okay, you don't waste time in this question. You cannot get a fraction. This is my measuring bubbles. Can the one whole bubble? All right. So I don't have to start adding all of these. In exam, if you try to add all this and divide by the number, you waste time. Just come. So it should be presented as whole numbers, 18 and 19. 2 and 3 is the answer. Okay, as simple as that. Just check it. 2 and 3 should be measured in whole numbers, not in fractions. All right, so 2 and 3 is therefore option B. No waste of time. So let's go to the next question. The diagram shows a metabolic pathway, reactant, enzyme. Okay, let's see. You can see that metabolic pathway. So what would be the effect of adding a small amount of non-competitive inhibitor of enzyme 2? Small amount. All right, as enzyme 2 would be the nature. Okay, let's go find out. B says substance X would increase in concentration. We're going to find out. C says substance Y would no longer be formed. We're going to find out. Okay, so which one do you choose? Okay, so you pause the video and then try the question. So look at A. Enzyme 2 would be denatured. Okay, now we're adding small amount of non-competitive inhibitors. Okay, and then it does not denature enzyme 2. Okay, it might partially, but it doesn't mean that all the enzymes are denatured. All right, I mean all the enzymes too. Some of them will still be working. All right, is that okay? Now enzymes, non-competitive inhibitors affect enzymes, but it depends on the type of non-competitive inhibitors. Some of them give a temporal change, some permanent change. So A is not the answer. B says substance X would increase in concentration. Now, if you inhibit some of this enzyme too, that means that what happens is that, remember that enzyme 1 is still breaking down the reactant to substance X, okay? But some of the enzyme, because it's just small amount of competitive inhibitor that's non-competitive inhibitors that's added, so some of them are working. So that means the amount of substance X converted to substance Y is small. So this would increase. That makes sense. All right, but check out C. Substance Y would no longer be formed. Who said that? Substance Y will still be formed. Why? Because some substance X will be converted to substance Y. Not all substance X will be converted. Not all enzyme 2 will be inhibited. Just some of them. Okay, and of course, so C cannot be the answer. This is initial reactant will no longer be metabolized. Okay, what is initial reactant? This is it. Enzyme 1 converts reactant to substance X. Enzyme 1 is not the one inhibited, it is enzyme 2. So D cannot be the answer. All right, so the answer is what? B. All right, don't forget that non-competitive inhibitors, they bind to allosteric site. Okay, they do not bind to the active site. So but when they bind to allosteric site, they alter the shape of enzyme, if you remember that. Okay, if you remember, let me show you something. So if this is an enzyme, it has another site called allosteric. You remember that? So this is the active site. All right, so let's assume that this is the inhibitor. Okay, when this inhibitor binds to it, when it binds to it, it's going to appear like this. So this is the inhibitor trying to bind to this. Sorry for my diagrams. When it binds to it, it alters the shape of active site, and then this is the inhibitor binding to it here. Okay, right? So it alters it. So this is the substrate is not able, right, to bind to it. This is S substrate, this is enzyme. So if the inhibitor binds first before it actually alters the shape, this alteration can be permanent or it can be temporary depending on the strength of this bond, the bond between inhibitor, all right, this inhibitor, all right, and the enzyme. All right, so the answer is X. Pause the video and check it out. So question 3 says, which of the following can increase fluidity of cell membrane at low temperature? Now this question is for cell membrane transport, and this enzyme is an enzyme question. Should we solve it? What do you think? Should we solve it, guys? All right, should we solve it or should we leave it? Since we're already here, look quickly. Double bonds means unsaturation. So the more double bond, the more fluid. Okay, because double bond fatty acid tail, they are bent, so they create more kinks. That increases fluidity. Cholesterol also can increase fluidity. All right. Fatty acid having shorter chains, yes, the shorter the chain, the more fluid. So all of them. But forgive me for bringing this question here. Let's go to enzyme. So two pairs of students each counted the number of bubbles of a given. Now this question again. Pause this video and check. But you don't need to waste your time here. All right, go check this. The only one that has whole number is 2. The answer is C. Don't waste your time. Bubbles cannot be 9.2. No. Okay, straightforward. Let's go to the next question. When investigating the rate of reaction of the enzyme lipase on hydrolysis of triglyceride, the pH must be maintained at an optimum to prevent the lipase from denaturing. Because what is the reason for this? These are the options. Yeah. So don't forget that lipase breaks down lipids. Remember that lipase, the enzyme lipase, we have lipid. So lipid, let me call it L. When it reacts with lipase, okay, let me call lipase LP, okay, it's going to break it down to glycerol. Let me call it glycerol G, and the fatty acid, about 3 fatty acid if we're dealing with triglycerides. So we have 3 fatty acid F. All right, so these fatty acids here, they are fatty acid, right? So they're acid, so they will change the pH. They will change it. They will make the pH more acidic. So if you check this, they said the addition of water molecules, of course, please don't forget that water molecule is added here, okay, by hydrolysis, okay, increases pH. No, water does not affect. Water is neutral. It's neutral. Okay, the product of hydrolysis decreases the pH. Yes, the product is fatty acid, it will decrease it. The product of hydrolysis increase, it doesn't increase it. The removal of water molecule used hydrolysis decreases. No, it is the product. So the answer is what? Is B. Let's go to number 6. How does increasing substrate concentration affect the rate of an enzyme catalyzed reaction in the presence of complex inhibitor? Now, if you remember, guys, if you remember what we learned, okay, in the effect of enzymes, the effect of the reaction, okay. If this is substrate concentration, this is X axis, Y axis rate of reaction. So the reaction without an inhibitor goes up like this, okay, it goes up and levels. But if you add competing inhibitor, it will continue to increase as long as you're increasing substrate concentration. So we keep on increasing substrate concentration. So what happens? The reaction will continue increasing because we have more substrate molecules. Remember that a competitive inhibitor has similar shape like the substrate. Now if this is the enzyme, don't forget this. All right, this is S, the enzyme. No, this is E, the enzyme. All right, I hope you are trying this question. And then we'll have, this is substrate. Okay, try this question. Okay, and then we have the inhibitor. Inhibitor looks like this. It's similar to the substrate, all right, but it's not exactly the same thing as substrate, but it's similar and it's complementary to the enzyme. So you see, when you increase substrate concentration, this, so the reaction will still increase. Okay, so say the rate of reactions of the reaction decreases. Nope, you can see it continues to increase. The rate of reaction decreases initially. No, the rate of reaction increases. Yes, it increases. The rate of reaction is not affected. Okay, it increases. Okay, so what do you think the answer is? Because C. All right, let's go to number 7. 4 students investigated the effect of catalyst on hydrogen. So look at this question again, guys. Pause this video and try to answer this question. Okay. Of course, the answer is C. All right. So okay. So yeah. So look at it. The time recorded. Anytime you see this kind of question, okay. Anytime you see this question, just go straight to the one that has, okay, the one that has whole number. That's C. C is the answer. You get? Don't waste your time. Students are wasted, their times are wasted by trying to do the average. It's not the average, it's about what you're recording. Okay, if you're counting, we record whole numbers for time in biology. Okay, or look at that question. So which statement about competitive inhibitors of enzyme actions are correct? Yes. So the same competitive inhibitor, increasing the concentration of enzyme substrate will reduce the effect. The effect, they bind to an enzyme at its active site. They reduce the activation energy required for reaction. Okay. Okay. What do you think is the answer? What do you think is the answer? Okay, let's get into it. Increasing substrate concentration of enzyme substrate will reduce their effect. Yes. I just drew, look at it now. I just did it now. The other question we did, if you have a graph, look at this graph. This graph is like this. This is graph of substrate concentration, S is substrate against rate of reaction. So without substrate, okay, without inhibitor, it goes like this and levels. Sorry, with complete inhibitors, it increases, and of course, and you see what is happening here. So increasing the concentration of the enzyme substrate will reduce the effect. Yes. Okay, that statement is correct. If we increase the enzyme the substrate, we're increasing substrate concentration. So if you continue to increase it, remember that substrate concentration will be more than the inhibitors. So they are competing with inhibitors for the active site because they have similar shape. So they will bind more to the active site, and then they will reduce the effect of the, all right, there's increasing the concentration of the enzyme substrate. Yes, so they will reduce the effect of the inhibitor. All right, so 1 is correct. All right, okay, look at 2. They bind to an enzyme at its active site. Yes, we're dealing with complete inhibitors. They have the same similar shape to the active site, so they compete for the active site with the substrate. So this statement 2 is correct. 3 says they reduce the activation energy required. No, it's only enzymes that do this. Inhibitors do not reduce activation energy. Enzymes. So 3 is wrong. 4 says they reduce the maximum rate of reaction. No, they don't. Okay, look at this. Look at this. Can you see this graph here? This graph. Look, complete inhibitor still reaches the maximum rate of reaction. Yeah. Okay. All right then. Okay, it still reaches. Sorry for the noise at the background. Okay, it's one of my colleagues. Okay, listening to the video. All right. So now, as increase of the concentration, this is the reaction still increases and reaches Vmax. Let me write it down. So this is Vmax. Can you see that? Yeah, that's Vmax. That's the highest rate of reaction. That's Vmax. So you see, just very important, this reaction here. So this is with competitive inhibitor, this is without inhibitor. Both of them still reach Vmax. So competitive inhibitor does not reduce the maximum rate of reaction as long as we keep increasing. See, as long as we keep increasing substrate concentration. So 3 and 2 are wrong. So what is the answer? What do you think is the answer? 1 and 2, correct? So let's go to the next question. It says an enzyme is completely denatured at 50 degrees Celsius. A fixed concentration of this enzyme is added to a fixed concentration of its substrate. The time taken for completion of the reaction is measured at different temperature. Look at this. Okay. So what is it asking us? Which graph shows the result? All right, guys, look at it. The dependent variable, the independent, is always on the x-axis. Okay. Is temperature. Okay. Then the dependent on the y-axis is time taken for reaction. And if you check, guys, remember, if you remember the relationship, so rate of reaction basically have dual relationship with temperature. So at the beginning, if the rate of reaction at the beginning, the reaction will increase, and when it reaches optimum temperature, it will decrease. Okay, that is if it is reaction between rate of reaction and temperature. Okay, so it will show us, the graph will look like this. It will look like this. Let me draw it here. The graph will appear like this. Okay, that's temperature, that's rate of reaction. Okay, that is if rate of reaction is there, it will increase, and okay, and then decreases after optimum temperature. Okay, but look, rate of reaction is inversely proportional to time. So that means as rate of reaction increases, time will decrease. Okay, and therefore temperature is also inversely proportional with time. So as temperature increases, the time for reaction to occur, right, will decrease. Okay, so look at it, guys. Look at it. Look at this. Look at this. So you see this cannot work, because this is telling us that as temperature increases, the time for reaction to occur increases. For time to increase, that is going to take longer time. But you know that as temperature increases, time for reaction to occur will decrease, because the reaction is increasing. It cannot be this, it cannot be this, okay? Because the reaction will always reach its optimum and falls, okay? We cannot be B either. It's not a straight line graph. So C and D eliminated. So it cannot be this. Okay, this is what explains it. As temperature increases, initially rate of reaction increases. That means time to react for substrate molecules to react to form product will decrease. So rate of reaction is increased. But when it reaches optimum temperature, the enzyme gets denatured. Or yes, as you continue to increase it, all right, time as you continue to increase temperature, all right, time, all right, increase. It takes time for reaction to occur. And you see, they said that it completely measures at 50. So if you trace this, this is 50. All right, so this is the likely graph for it. So what is the answer? The answer is A, that graph there. All right, which is correct for a non-competitive inhibitor of enzyme action? Right, increasing the enzyme concentration of the enzyme substrate will reduce it. Okay, reduces the activation energy. Okay, let's see. So which one do you choose, guys? Watch this. Let me show you the graph if you don't know the graph. So we have this graph. Okay, now remember, this is substrate concentration, this is rate of reaction. Remember, the reaction without inhibitor goes up and then levels. With competitive inhibitors, okay, still continues to go up and reaches Vmax. With non-competitive inhibitors, okay, it just goes up and stays, levels up. It does not reach the Vmax. So this is non-competitive, this competitive, this is without inhibitor. It says increasing the concentration of the enzyme substrate will reduce its effect. No, it does not reduce its effect, because even if you increase the enzyme concentration, sorry, the substrate concentration, all right, it does not reach the highest rate of reaction. stops here. Does not reach, stops here. This is the highest rate of reaction. This does not reach, even though we are increasing the substrate concentration. Now 2 says it reduces the activation energy required. Now activation energy is only reduced by enzyme, not substrate, not inhibitor. Enzyme. So this is wrong. It reduces the maximum rate of reaction. Yes, that's what it does. Okay. So look, the maximum rate of this reaction is here. This is the maximum. That's V max. Okay. It reduces it to this. Trace this. Okay. This is another V. Alright. So it reduces this from the highest to the lowest. That is what non-competitive inhibitor does. So 3 is the only correct answer here. Okay. The only correct answer here. So the answer is B. Alright guys, just like the video, share it. We're going to be going into series 2. Sorry for the interruptions, sound at the background, all right. Just make sure you're following us and making comment. Thank you. See you next class. Right. Bye.